going to start showing my screen right about now.
Good afternoon, everyone. This is Britton Baxter with the Corporation Commission, as Noah just stated.
And this is Andrew Smith with the Corporation Commission as well.
We're both very happy and honored that you've asked us to speak with you today, and hopefully the information that we share you'll find useful.
All right, one moment. Are you guys able to see that screen on your end?
We are not.
Okay, one moment here.
There we go.
We got it now.
Okay.
Oh.
Now, there it is. Okay. You got it?
We got it.
Okay, so go ahead. Take it away, boys.
Okay, if you want to go ahead, Noah, and show the next slide.
There seems to be a bit of a delay, sorry.
It's okay. So as Noah mentioned, recently the Commission adopted a policy called Collaborative Commission Approach to Mitigating and Measuring Water Loss. This was issued about a month ago, and it in essence boils down to four kind of big broad categories. And we're going to give you a little bit more information about each of those categories today. So next slide, Noah.
So the first category that the water loss policy statement boiled down into was the methodology statement. And I'm not going to steal Sarah's thunder because she's going to talk about this in a little bit. But the first thing that the Commission directed staff here at the Commission to do is to invest in the WIFA ADWR water loss pilot project. Like I said, I'm not going to tell you much about that because you're going to learn about that in a second. But we're going to ensure that ACC and small water utilities are represented in the actual pilot project. And this was important to us because we needed to make sure that the small systems were actually represented. And for us to take a look at the actual water loss methodologies, specifically the M36, we need to know how that would impact small water systems. As many of you know, small water systems are quite a challenge to make sure that they get their water loss under control if we use just a standard, gallons pumped versus gallons sold methodology, just because the numbers are so small that they can actually show quite a big proportion of actual water loss. So long story short, we just wanted to make sure that those utilities were represented. So we did in fact get two Arizona Corporation Commission regulated utilities to be a part of this project. And then the second part of that is that we're supposed to lend expertise and knowledge as appropriate. Again, we're attending all these meetings with a pilot project and making sure that we're asking questions of the consultants and of the actual participants to make sure that we're understanding how this is impacting them. The second part about that, if you want to just go back one slide, is the review and recommend adoption or a part or all of the M36 manual. So the Commission directed staff to really take a look at this M36 methodology and look how it would impact the wide range of utilities that we have here at the Commission. It does recognize the M36 as being the national standard and recognizes that many states have undertaken that as the actual standard for which they want to calculate water loss. And so we're looking at how that, if we were to undertake that, how that's going to impact our utilities, and do we have the technical expertise to actually require utilities to do that, or do we need to, look outside to actual hire consultants to come in and assist the utilities with collecting that data? So a big part of that is the pilot project, and that kind of ties into this M36 methodology. The second part about that is it directs us to work with ADWR and WIFA to determine appropriate performance indicators to measure and data collection and validation methodologies. So again, if we're not, the commission kind of left it up to staff to really figure out what's appropriate. And so we're looking at all of those indicators that tie into the M36 method and saying, which ones are appropriate, which ones are not, or do we just take the entire method and adopt that as the standard?
The second part of the policy covers the collaboration and institutionalization. Government agencies and their acronyms. So the commission directed staff to formally establish the Water Reform Working Group. And what this is a data collaboration project between DEQ, DWR, and ACC. And we're currently working through developing a business or a project plan with the end goal that we'd like to have one web portal where a water company could go to and submit all the information that's collected from the three agencies at the one, excuse me, at the one time, and then each agency will be able to receive the information that's specific to that agency. So we're pretty excited about that effort. And as Andrew mentioned, we've also been directed to work with DWR and DEQ to streamline these data collection efforts, and that's where the idea of a web portal really comes in. But another thing that we will accomplish through this sharing is some consistency in reporting requirements and hopefully timing. And they also directed the ACC Small Water System Ombudsman Office to partner more extensively than we currently are with RWIC on technical and financial assistance initiatives. So next slide, please, Noah. Thank you.
The next part is the culture of conservation, and the commission believes that reducing water loss should be done in partnership with other state agencies and regulated utilities. So you're seeing a common theme here of collaborative effort among agencies. There's a lot of, I wouldn't say duplicative, but similar efforts, in terms of water loss. We have the Department of Water Resources and Department of Environmental Quality and the ACC that are all interested in water loss. So how can we streamline those and get us all pretty close to what we can adopt as a similar method? Also, they were directed staff to expand their outreach efforts for small and rural communities. So again, making sure that we're hitting all areas of the state, making sure that we're leaving no utility uncontacted or without assistance. And the final thing is directs staff to explore hosting rural workshops. So we're looking and planning right now to actually attend some of these workshops and host in different regions throughout Arizona to hopefully make it easier for utilities to not only work with the ACC, but our partner agencies as well to, idea share and tell them, what's up and coming as far as the water loss methodologies at the commission. The final point was the continued research. There was kind of this, topics that really didn't fit in the other categories. So first and foremost, the address the water energy nexus, which obviously this committee would be very interested in, is other states have done a lot of research regarding this, the tying into the idea of, the more water you pump, the more energy you're using. And if you're losing water, then that's a burden on the actual electric grid as well. So we're looking into that and starting the steps in preparing something regarding the water energy nexus. Additionally, we want to look at other states' water loss methodologies. Like I mentioned before, we've recognized that other states have adopted an M36 program. I believe Georgia, Ohio, a couple of others as well that I'm missing have actually adopted this method, California as well. So we're looking into how they run their program and maybe how we can tweak ours to better fit the needs of Arizona. And finally, we want to explore more financing opportunities, and it directed, like Brett had mentioned, the ACC Small Water Ombudsman Office to prepare a report on financing options available to utilities. As you mentioned before, we're taking a bigger leap forward and participating in what you mentioned as RWIC, which is, for those that you don't know, it's the Rural Water Infrastructure Committee. It's where systems can come in with a project or a capital improvement project that they want to undertake, and listen. The group can hear it and offer assistance. So there's lots of different agencies, rural development, WIFA,
USDA.
Yeah, USD. Well, yeah, rural development. RCAC, just a lot of different partner agencies. That's kind of like your one-stop shop for actually undertaking those financing. So it's a great move forward on our part. And the last part was to review the applicability of system improvement funds. So that's mainly here at the commission for systems that want to undertake capital improvement projects between rate cases. So we're looking at how we can better improve those, or if they need to be done differently. So we're looking into all of that.
And to elaborate on the system improvement funds, that would typically be through a surcharge that a company would collect from its customers to pay for, like, a meter replacement program.
Next slide. And I believe that's all we had. I'm happy to answer any questions, but our contact information is on the slide. You can reach either of us at the phone numbers or emails listed.
Very well. Yes, thank you, Britt and Andrew. And like I said, the questions, if you have questions for them, please just type into the questions tab, and at the end of all the presentations, we will get to them. All right, so moving right along, our second presentation today is going to pony onto that, discussing the WIFA ADWR water loss pilot project. And as you heard Britt and Andrew allude to, part of the charge with that ruling that they had was to look at ways to work with local agencies, and this pilot is one of them. On your notice, you may have seen that Susan Craig was listed. She was unable to make it today, but her colleague Sara Conrad is here, who is a senior program administrator with WIFA. And so with that, I'm going to turn it over to Sara, and please go ahead.
Okay, thank you. Hello, I'm Sara Conrad with the Water Infrastructure Finance Authority of Arizona, and I'm really pleased to be here today to tell you a bit more about Arizona's water loss control pilot program. And of course, a thank you to NOAA and the Arizona Water Association for the invitation to speak here for just a few minutes. The next slide, please, Noah. So WIFA, which is the Water Infrastructure Finance Authority of Arizona, kicked off with ADWR, a partnership of a water loss control pilot project. ADWR, of course, is the agency that's concerned with water resources and water loss, and WIFA manages the state revolving funds. So we've got funding available to do water audits, leak detection studies, as well as the capital improvement projects. So it's a natural fit for our two agencies to work together and initiate this program. We've seen the successful implementation of similar programs in other states, and so we thought, let's do one here in Arizona. It is a pilot project, so it's a small pilot project, and we're just taking the first steps towards determining the feasibility of this water loss program among utilities across the state. We selected Kavanaugh as the contractor for the pilot project because they've implemented similar water loss control pilot projects in several states, and they use the American Water Works Association manual for water audits and loss control programs, or the M36. Next slide, please. And of course, we're not doing this on our own. You've just heard from Andrew and Britt at ACC, who we work very closely with, as well as our colleagues at DEQ and the EPA and AMWA. And of course, Arizona Water Association is holding trainings just like the one we're attending today. Next slide, please. So for our pilot program, we selected 6 systems in total to participate. Like I said, we started small, but we did have some criteria. We first of all wanted them to be outside of active management areas, and that was a criteria of ADWRs. We also wanted to make sure the systems had greater than 10% water loss. We wanted a sampling of both public and private utilities, as Andrew mentioned before, as well as a sampling of different sizes of service populations. but most importantly, we wanted them to be systems that had the potential to implement water loss recommendations and systems that had supportive leadership that would embrace and champion the M36 methodology. Next slide, please. So we selected these 6 drinking water systems. You'll see that we have 4 public utilities on there: the Town of Clarkdale, Pine Strawberry Water Improvement District, City of Kingman, and City of Flagstaff, and 2 private water companies. We have Global Water, which has a small system in Tonopah called Eagle Tail, and Arizona Water Company, which has a small system in Sedona called Pinewood. So you can see we met our criteria of both small, medium, and large service populations. The water loss data, we found a couple interesting numbers, like the one for Pinewood. So we wanted to get in a little deeper to see what was going on there. So these were the systems that we selected, and these 6 systems are receiving free training from Kavanaugh on how to apply the M36 methodology. And then they're going to be determining the magnitude of the losses, the sources, and then what they can do to correct them. Next slide, please. So we kicked off this project back in September with an in-person training for the 6 systems. And since then, the systems have been hard at work gathering their data. All of their data was due to Kavanaugh last Friday. So now Kavanaugh is just starting with the compilation and analysis of the data. We're going to have an in-person work session in January, a 2-day work session for those 6 systems to start plugging in those numbers into the spreadsheets. And then there'll be some post-work activities, and then Kavanaugh will be producing a water loss auditing report for each of those 6 systems by April. So our next steps, we're still determining what those might be. Of course, we want to see what the survey holds and what those reports show us. We're definitely interested in what the challenges are that the systems had, if they had any surprises, and of course, how they're going to implement the findings of the audit. That's very important to us. And we also want to see how we can help these 6 systems move forward, and then also how we could help systems around the state. So we've got a lot of questions to be answered, and we're going to look at these outcomes and make a determination about doing a water loss study broader in scope than this pilot project. The next slide, please, Noah. And ultimately, I think I might have mentioned this a couple times, both WIFA and ADWR want to see the results of the water loss implemented through a capital improvement project or whatever needs to happen to reduce the water loss. These projects can be funded through WIFA's Drinking Water State Revolving Fund. We have 2 types of funding available there. One is our set-asides, which is what we were using to provide to fund this pilot project. So technical assistance, water audits, leak detection. And then for systems that have identified any capital improvement projects to be implemented as a result of these studies and audits, we have our loan funds available for them as well. Next slide, please. So this is the contact information. We would love to hear from you if you'd like some more information about what the next steps would be. We have a distribution list that's right up there on the top. We'll be sending out an email, I'm assuming late spring, early summer, with what the next phase might look like. And if you've got any construction projects, any capital improvement projects you're looking for funding on, please give me a call. My phone number and email are there at the bottom of the screen. Thank you.
All right. Thank you, Sarah. Now we'll move into the meat of the presentation here. The third presentation is going to be water auditing and leak detection. The presenter is going to be Andrew Chastain-Howley, who's a Director of Water Solutions for Black & Veatch. And in one moment, Andrew, I'm going to turn this change presenter over to you. And then we'll just make sure it's all working. And if not, I can always walk through it again. So.
Sure. And just a sound check.
Yep, I hear you.
Noah, can you hear me okay?
Yes, sir.
Perfect.
Okay, so I have you as the presenter. There you go. Looks like you're already on top of it. Perfect.
Can you see me?
Yes, sir.
Perfect. Very good. Good afternoon, everyone. So as Noah was mentioning, and Sarah, Andrew, and Britton as well, this is a focus on, the collaborative mechanisms to improve water efficiency realistically and to, focus in on water loss. I'll just give you a quick bit of background so you know where I've come from. I've been over in the States for the last 20 years, so don't let the accent fool you. But I started off in Yorkshire Water over in the UK, in this industry at least, in the mid-90s, and I'll get to some of the details about the chronology of the water audit as well. So just to start the program, these are the things that I'm going to connect to. I'm going to go into a little bit more detail beyond what the other presenters were mentioning, not truly into the weeds. We don't have enough time to do that, but at least some overview of the AWWA's N36 methodology as such, some of the data that you need to look at. I know a lot of the people on the phone will already know some of these things, so forgive me if you've heard it before. But we're not going to walk through specifically the water audit, the free water audit, software itself. I don't think we've got more than enough to discuss without that. But I can target you into the major pieces of it, so that when you use it, you'll be a bit more up to date with it. And then I do want to spend a significant amount of time just looking at some of the, how you determine the water losses and some of the mitigation techniques as well, because obviously that's what Sarah was mentioning at the end, is that at the end of the day, we can push the numbers around as much as we like, but we've got to find some reductions in the water losses wherever they come from. That's the focus of all of this. We need to do a lot of data analysis and field work and other things, and the pilot study and things like that as well. But we do need to get to obviously determining what needs to be done to improve that water loss for individual utilities and for the state. So let's just look at the M36 methodology just to begin with. As I said, I'll give you a chronology, then we've talked briefly about state programs. I'll go into that in a little bit more detail. Andrew and Britton were mentioning that. Then I'll connect to the methodology overview. And I want to focus in, before I go to the next phase, the validation as well, which is hugely important to this sequencing. So here's a little sort of chronology of the, I put it as the IWA/AWWA water audit history. What I've got in here is the AWWA's water audit history realistically. But before that, the data that you see on the screen starts in 2001. But realistically, it started in the mid-80s, but it took, over in the UK, there was a number of items that were being developed, but it didn't really gain traction, this specific methodology, until 1995, when there was a major drought in Yorkshire in the UK. I joined the utility in '96, and so they'd had some major issues. They'd actually had to, people were going with bottles and standpipes to get water in certain situations, because the drought had caused the distribution system to fail in certain areas. I think at one point there was about 300,000 people without water. And this is obviously in a first world system. And that drew a lot of regulatory focus to auditing of the water system, because it was determined that it was poorly audited and analysed, and there was a significant amount of leakage, which actually caused the issue. If they'd have fixed many of the leaks, Yorkshire wouldn't have got into this problem in the first place. So the International Water Association worked very hard after that, up until 1999, when they put the actual standard method out into publication. And then AWWA took it on about 2 years later. They evaluated it, and their Water Loss Control Committee within the AWWA approved it as the standard methodology. So that's the beginning point that you can see on the graphic there. But what I've tried to lay out is some of the sort of sequences. If you look down in the bottom on 2005, AWWA Water Audit Software Subcommittee initiated, and then the next year up above, Water Audit Software version 2.0. That was actually the first version. I was the chair on that group developing the software, but we needed, that's a precursor to what you'll see during this session as well. So that was to try and allow systems to not have to go through the calculations themselves, just to develop the information, which we'll talk about over the next hour or so, and to be able to just basically plug in the numbers and all the calculations and the performance measures that were developed by the IWA and AWWA were able to be calculated. And there was the M36 manual, which has been referenced a couple of times. You see in 2009, and then there's an update in 2016. So the version 3 of the M36 manual was actually the first one to take on the new water audit structure. And then the version 4 has been significantly updated. As an example, evaluation of production metering has been significantly updated in version 4. But that's the Bible as such. It's been developed by the Water Loss Control Committee, and there's been input from many different utilities and individuals to make that what it is currently. It's realistically on a 5 to 7 year cycle, so there will be another version, obviously somewhere around 2021, 2022, and that's already being begun. So it's an active living document realistically. And then the other thing to mention here before I move on to some of the state programs is the sort of the validation programs that are ongoing. 2012, the Georgia Water Audit Validation, that was developed by, it was consultant led, but it was the EPD that was driving it. And they've also got a water infrastructure finance group that's helping to provide money to especially small utilities and underprivileged utilities to help with meter testing, leak detection, and all those things. And so that's a pretty important one. And then Tennessee, Texas, a number of other states, and I'll show you a bit about that in a minute, have developed it. And then the California validation program that was mentioned just earlier as well. That started realistically in 2016. It's running mainly through 2017 for all the utilities of size in the state of California, and that should be the first phase of that should be reaching completion at the end of this year. So I'll try and connect to the next.
Actual presentation, and then hit the arrows. Okay.
So one of the items that I want to, I think are we good? Can you see it now, Noah?
Yes, we're good.
Hopefully you can. So it's very good. So droughts, what I want to connect to is that droughts drive a lot of the water auditing. In Arizona, it's obviously a different case because realistically, the rainfall, it's depending on how you look at it, it's always in drought, but you've also, most of the utilities have been living with that all the time. So it's a bit of a different dynamic here in Arizona. But I just want to show you mention a couple of the items that have driven this program across North America, at least. I mentioned about Yorkshire, and that was driven by drought as well. But the drought of 2008 through 2010, there was the Water Stewardship Act in Georgia that was developed in 2010, and that drove the validation programs that they utilized. Texas had a couple of droughts, actually, one in the early 2000s, 2004, 5, 6, and that got the state interested in auditing of their water systems. And then there was another major drought in 11 through 14 that made them think once again. They were looking at metrics for a long period of time as well. Georgia went fully with the AWWA M36 methodology, and they're using the water audit software as well. Texas used the methodology, but they had their own database structures. And just like Andrew and Britton were talking about, they actually, they're in the process of finalizing putting three databases together to allow reporting just on one platform for conservation, for utility usage, and a couple of other things as well. So they're doing it through their own sort of database structures online. And then California, as we connected to earlier, I know their drought sort of started in 2012. To a degree, it's finished now, but that's in certain parts of the state, it's still ongoing. And that's what drove a lot of the focus on water loss auditing and water loss reduction with the program that I mentioned there as well. You can see some light blue states and dark blue states. That's it's not completely up to date, but that basically is saying those that are red or dark blue have some kind of water loss reporting mechanism. There's a couple of others in there as well. New Mexico has one as well, but it's more dedicated to individual utilities rather than across the state. But yeah, there's a fairly wide range, and it's increasing year on year as to who's got some kind of auditing structure. Not all of them use the M36 methodology yet, but I would say a majority of them do and have some kind of structure that relates to the M36 method, and I'll get into that one in a second here. So that's the sort of the broad overview. So let's get into the method itself. So what you're seeing, the little screenshot there, is an example screen, the reporting worksheet from the AWWA's free water audit software. So this is it's based in Excel, and it is the white cells there are data inputs, and the yellows are calculations. So it's set up so you can input up to about 18 data inputs as a maximum, and it will provide you with what we class as a top-down water audit. So this is what we're talking about today with this standard audit method, realistically, and the software develops a top-down. So this is the data we already have on how much we produce, how much we bill, and a whole host of other items, and you plug those numbers in, and it develops a water balance. And there are other methods which are part of the M36 methodology as well. One is component analysis, which looks at leaks and breaks, and another one which is a bottom-up analysis, which is realistically with field work, and we can talk a little bit about those as we go through. But this, again, it's AWWA, IWA, and it's about reviewing and validating the data information. And it does, one of the most important things I would like to stress is that it does require champions. As Sarah's suggesting, all the 6 utilities that are in the pilot program, one of the requirements for them was that the leadership will champion this work. It doesn't mean that they're going to rubber stamp it. It just means that they're going to champion it and to try and push good work down the track to provide the data and to make sure that this is a valid way of doing things for the utilities in Arizona. And you definitely need to involve all the departments. I've just listed sort of 4 areas there, but depending on your specific utility, you can even be talking. I do this all the time, and I was just over the last few days been talking with the utility, the Parks and Recreation, and the Sheriff's Department, and the Fire Department as well. All those have small pieces within this that you need to involve them and get some of their data if you're going to do it properly. But obviously the main ones are operations, maintenance, billing and finance, treatment, plant production, or if you purchase, then obviously the wholesale entity that provides the provider providing water to you, and then obviously the engineering and administration departments as well. So this next slide is the overall water balance. So this is in the N36 methodology as well, and this graphic's been used in many different forms to explain the overall structure of the water balance, of the overall water audit structure. And it's, as I've put in the top left corner there, it's about accounting proactively rather than reactively. A lot of utilities have in the past done, this is how much we produce, this is how much we sell, and that's the limit of the development of an audit of the system. This is just what you're seeing on the screen here is sort of the overall development of that. I'm going to just connect to the areas in the center first. So whether you can see my cursor or not, but where it says authorized consumption and water losses, that's our main focus. You can export water, you can import water, you can have groundwater wells, surface water systems that provide the production information into the overall amount of water supplied into the system. And we're then trying to break it out into what's authorized and then what's water losses. And obviously, as we've mentioned before, the focus is to understand the water losses, get that as accurate as possible, and then to mitigate them, to reduce them. So with respect to, and this can be a whole multi-day analysis and an education process, I'm just going to go through the basics of it here. So please don't expect to know all of this until you go through that process, but just to give you a frame. So there's realistically there's 4 components of authorized consumption realistically, once you take exported water out of the equation. When you export to other utilities, their losses are their own, so you don't account for them in your own analyses. But the authorized consumption internal to a utility, I'll just go through them quickly, is billed metered, billed unmetered, unbilled metered, and unbilled unmetered. That just plays on the words in many cases. But 2 are billed and 2 are unbilled. In most utilities in Arizona, it's metered, 100% metered. And so that's the major component that you want to put in here. But there are some unbilled and authorized, both metered and unmetered, firefighting, flushing, city parks if you don't bill them, those sort of things that are authorized consumption, but you don't receive any money for them. And that's important to break out because we need to also work on costs here to work out how much is being lost. And then obviously the focus is on the water losses, and they're split into 2. I'll do the last one first, the real loss. That's what most utilities think of when they very first come to this, which is leakage on a system, whether it's transmission mains, whether it's distribution mains, or other items too, such as overflows from storage tanks. Then the apparent losses are split into 3, and that's unauthorized consumption or theft of service, customer metering inaccuracies, so how accurate are your customer meters, and systematic data handling errors, which are any errors from when the customer meter is read to the customer receiving a bill. So if there's a meter multiplier that's wrong, or a 0 that's incorrectly assigned, classifications that are incorrectly assigned, those losses go in that location. So that's a sort of a broad overview to it. And I mentioned validation is very important here. And there's 3 levels of validation. And this is structured as well through, there's a number of there's a number of documents that have information on with respect to this beyond the M36. But this is from Water Research Foundation work as well. There's been work specifically on validation. And I don't want to go into all the details of this, but realistically, level 1 is a top-down review, just what data you have, and put into the M36 methodology. Level 2 is doing more detailed analysis of the billing system, of the supply, so the production metering, data mining of that information, actually looking at the data and seeing where the gaps and details are and trying to do some layer of statistical confidence on those components. And then the level 3 is field investigation, going out and doing leak detection, doing some specific analysis of the field, of the meter accuracies, both at the production level and down to the retail level as well. So those are some of the levels of validation. And then let's just connect to some of the data that's required. And so, again, we don't have enough time to go into all these different items, but water supply. So if you're a groundwater system, how much water is coming out of those systems, how much is pumped to waste, what are the accuracy of the metering systems that come out of the groundwater and straight into distribution. If it's a water treatment plant, it may be a bigger meter, a Venturi or a mag meter, which needs to be calibrated rather than just flow tested. You need to look at all these different pieces to see how confident you are in the data. The authorized consumption is all the billing, billed and metered, and the firefighting and flushing information if you can get it. Then obviously we need to look at the accuracy of the metering systems. And then there's 2 other items I haven't mentioned yet, which is system information. So we look at the number of miles of main, the number of connections, and in Arizona, there's one additional in the northern climates. But in Arizona, there's just 1/3, which is pressure, sort of average pressure in the system. So we need to know those to help develop the performance indicators. And then there's obviously cost information. So if you don't have any value put to the losses, you might chase things that you shouldn't, because it's either there's not enough money in it, if that's your goal. Or else it might be, oh my goodness, this is a lot of money that we're losing, so we better chase it pretty quickly. You always need to put cost information in there as well. And then we'll get back to data validation once more. So there's 20 water audit inputs. So obviously there's a huge amount of information depending on how detailed you want to get into each of those data inputs. So for example, volume sources is one, and that's all the production metering, all the production meter data, whether it's groundwater or surface water. And there's a whole host of information that can go into that value. And the methodology, audit seems to be a bad word because it relates to the IRS in many ways, but that's not what we're trying to do here. We're trying to improve the efficiency, but we do need to make sure there is a paper trail for the data as well. So any data files that are put forward to calculate and to put data inputs in here, those need to be recorded as well. There's a lot of information usually in the GIS. It's important to have on-site internal meetings, process discussions, field visits. All of these things are part of the methodology. And again, just to reiterate one of my earlier slides about all the different parts of the utility. So you probably don't need me to connect to this, but operations, maintenance, engineering, obviously it's the production side of things, that's pretty important. But they're involved in that unbilled, unmetered. So that's flushing of the systems, both water and sewer, street sweeping, firefighting and hydrant flushing and things like that as well, that might not have been considered in the past. And then customer services and billing and finance get in, their important pieces, the billed and metered, and to a degree the unmetered and unbilled consumptions as well, if it's recorded, and the details on theft of service and meter accuracy, and they often provide a lot of the system data as well. And you can see the others. The other pieces that are often pretty important when you get a little bit further down the track, is management of the data. As I was sort of mentioning, that audit trail, but it goes beyond that in terms of the analysis as well. And then there's always prioritizations. There needs to be a prioritization step at the end, which is, okay, well, these are all the things that we need to do to both improve the data and then reduce the water losses. But there needs to be a prioritization program as well, which looks at cost and other specific priority mechanisms. And so one thing I sort of alluded to, but haven't gone into in any great detail, is validation. So there's a specific validation methodology within the M36. And so that is, how good is the data? It's not dealing with the water losses themselves, although obviously they're very, very important. But if the data is incorrect, then you're not going to be able to target into the degree of water losses and where they are. And so there's a specific validation process that's standardized by the Water Loss Control Committee, and there's a validation checklist, and it generally follows a sequence of interviewing all the different utility areas. And there's a number of ways you can do it, but within the structure, the software itself has a data grading score of 1 through 10. 1 being we're guessing everything, 10 means we're measuring everything and testing and calibrating it on a very regular basis with respect to metering. You know, each of the different data inputs has different criteria. And those, again, that's another area which we could spend a significant amount of time on going through it. But realistically, it's a 1 through 10 scale for each and every one of the data inputs, and all the information that relates to that. There's a matrix that relates to that on the water audit, in the water audit software and in the manual N36 as well. And the software, I should mention, it is freely available. You can download it if you haven't already. I'm sure a lot of people on the phone already have been accessing that, but that's where it is. And one of the reasons for doing both the validation and this kind of auditing is, well, it's sort of the data that we've got up the front here. So I was lucky enough to be involved in the Texas did it first, 2,096 utilities in the end, just over 2,046 at the beginning when this data was put out. And so they went through the audit structure. It was all self-reported, and there was a significant amount of utilities that had these specific performance indicators that I've related to here. They're not really performance indicators, but they're key indexes to relate to whether the data is valid or not. And so you can see some of these examples here. So some of the utilities, 115 of them, when they did the self-reporting the first time, they didn't have any water supplied. They had negative losses, which are obviously not possible. So it's part of the process is to go through the methodology, get some education for it, go through programs like this one and many others, which I'll connect to before we finish, because it takes time. It takes time to get it right. It takes time to understand the methodology. It is relatively standardized, and it's got some simplicity to it, but there are a couple of complexities that drive this kind of issue. But yeah, it just takes a bit of time, and it gets into it. The software was developed so that utilities didn't have to do the calculations themselves and didn't get messed up with those calculations and causing problems like this. But California and Texas had significant amount of the first reports that had data errors, and that's one of the reasons why they've gone into analyses of other using other validation methods. And I'm sure that's what ACC is going to connect to as well over time and with it. So just that's so the broad overview of the water audit software. Realistically, again, we could go through the Excel sheets themselves, and I could give you some examples. I'll mention one thing now, and I'll mention it at the end as well. There is the North American Water Loss Conference, December 4th and 5th, so just round the corner in San Diego. And before I finish, I'll put up on the screen the details for that. So if you want to get into more detail on any of these items, there's a number of programs there that are developed for both beginners all the way through to expert utilities. There's going to be 2 days, 3 tracks of just water loss. It's probably the preeminent. It happens every 2 years. It's between that and the International Water Association that's held in the opposite years. They're probably the most high-profile water loss conferences in the world. So that's happening just around the corner if you're interested. But that's the overall structure of the software itself. So benchmarking. Obviously, utilities want to see where they sit compared to their peers. And so I'm just going to give a quick frame around some of that information. We've been doing this work and benchmarking and going through validation of water audits for about 10 years now, a little over 10 years in North America. And we have a number of data sets, and I'll just show you one of them. So in 2009, we recognized that utilities wanted to connect themselves to peers, and not just A through Z, these are other utilities, but be able to actually connect to specific city names and data so that they can, there's a little bit more trust in the information. And so we developed what we call a water audit data initiative. And there were about 25 utilities in it from the beginning. There's been about 50 utilities over the years. And we are conducting it this year as well. It's probably going to be the last year for a couple of years. But every year since 2009, there has been this program where they've gone through the auditing process, the utilities, and then a group within the Water Loss Control Committee of AWWA have done a basic validation on those audits on an annual basis. It's all voluntary, but that's why the data set isn't bigger than that. But these utilities allowed their data to be presented with their name associated with it. It's on the AWWA Water Loss Control website, so you can go there and download it. There's a couple of papers there as well describing it, but the actual data's there too. And that's hopefully helpful to utilities to see what other people have done and what they're measuring, and a little bit their problems and trends as well. And as you can see, some of those utilities down the bottom have been in it all years. And so here's just one example. I haven't gone into the performance indicators up to now, but I will reference related to this. One of the performance indicators is gallons per connection per day of water losses. Gallons per connection per day. And you can split those up into real losses. So if you remember, real losses are leakage, and then apparent losses are the meter inaccuracy, the theft of service, and the data handling errors. So the blue bars are for these utilities that hopefully you can see down the bottom, Greater Cincinnati on the far left, Water and Wastewater Authority of Wilson County, that's Tennessee all the way on the right. And the blue bars are their water losses in gallons per connection per day. The red, if that's what you're seeing, the lower bars are the apparent losses in gallons per connection per day as well. So you can see that some utilities, City of Wilmington, Delaware out there on the far right, has, and this is actually a couple of years old, this graph, so they're a little bit lower than this now. This has driven them to do some more work on it, but about just a little over 150 gallons per connection per day of leakage in their system. And then you can see some of the others anywhere from close to 0 through to 50 gallons per connection per day of water loss on the apparent side. So we can get into all the details of that as we go along, but you know, there's some data for you to sort of measure and to analyze and see if you're in ballpark with in comparison to other utilities as well. So I want to focus the last part of the conversation. I probably want to try and finish in the next 15 minutes or so that it gives, I don't take everybody's time all the way down to the wire. But just want to look at some of the water losses and mitigation techniques, having a little look at the water balance again, and connect to some of the real loss and apparent loss and data management items. So I'll spin through this. So here's the water balance again. I just want to focus on this non-revenue water component, the unbilled authorized, the apparent losses, and the real losses components as well, just to reference once more before we get into those mitigation strategies. So these are all non-revenue water. Unbilled authorized, that first piece, social institution usage, city facilities, parks, all those sort of things, operational flushing, and other internal uses, and firefighting and flushing and things like that. And it can often include treatment plant usage depending on where you use, especially in the wastewater treatment plants, because you will use potable water. Some of the water treatment plants, the potable water is used prior to it getting outside the plant as such. But those are things to look at. And then in the apparent losses again, the inaccurate meters, billing issues, and theft of service. I won't go into the details there, other than looking at the focus is there on expanded meter testing and replacement when they're determined to be inaccurate, and then the billing forensic analyses and the field validation are very important to look at theft of service. And then physical loss. This is the first time I'll have mentioned DMAs, but the second bullet there, customer logging, and I've selected DMAs, district metered areas. I'll get into that in a minute, but it's a way you can measure the real loss. It's a bit beyond what we're doing here with the water audit, but I want to just mention it so you can get some frame of what to do next as well. And here's just an example from one utility, some of the example recommendations that came out of the water audit, of putting all that data in, doing the balance, doing a validation as well, and coming out. So a lot of times there needs to be production meter flow verification to make sure that the metering systems that are currently operational at the sites are valid, and you'll do electronic calibration depending on the type of meters, and physical flow testing as well. Proactive leak detection, proactive being the most important word there. A lot of people do, okay, this leak is surfacing, let's go fix it, and let's just try and fix it as quickly as we can. Of course, that's important, but proactive listening and leakage detection is hugely important to reducing the real water losses. They'll just stay stable otherwise, or increase in some cases. Anomaly analysis that relates to the apparent loss. The second bullet there probably being the most important at this stage, identifying high-risk accounts and going and searching and dealing with them. And then obviously that relates further down to meter testing and data management of the meter testing, so that you make sure you get that right. These are some of the things that this specific utility came out as priority items. So real loss and leak detection. So this is the portion of the system water balance. Again, leakage from overflows, and then the different portions, leakage from transmission, distribution, and service connections. In the overall, the water audit software itself, you don't break out leakage. In the M36 methodology, you do, but just keep that in mind if you use the water audit software. That's the first piece to the puzzle, but use the M36 methodology to go into more detail, and it connects to how to break out this information. It's rare, relatively rare within a community in North America to have major overflow at service reservoirs. Occasionally it happens if a water treatment plant, if a level sensor isn't working and there's overflow there generally. It does happen occasionally, but it's generally, real losses is generally leakage of some form or fashion. And so the ways to actively look at that there's a number of different methodologies. Most that people know about are the acoustic surveys, the sonic surveys. So sonic survey I class as a boots on the ground listening sticks or ground microphone to improve the sound for a field operator. The correlation surveys use more sophisticated and more costly information, which have sensors which are connected to items on the pipe, either a valve or a connection, a hydrant, and the computer is assisting the field technician in understanding where there's a leakage between those points. Noise logging is more automated. It's where you can leave logging units overnight to do a similar either sonic survey or correlation survey, depending on the specific type of equipment. And then step testing is old school, but it works very well, especially in old utilities where it's a little problematic because you have to close down the system. You close down separate portions of the system and monitor the flow that's going in there. And obviously, if you see a large increase in flow when you open up a new area, or vice versa as you close an area down, if you suddenly see a reduction in flow, then you can be pretty certain that the leak that you think is there is in that section of pipeline. It's a little bit more detailed than that, but that's a basic overview of step testing. And then the transmission main surveys, obviously for the larger size mains, you have a significant change in what you need to do. That acoustic signals just don't travel far on large diameter pipes, so you need to have a very different way of doing analyzing that information. And that's a completely separate study. And then some of the infrastructure that you might need to put in. So district metered areas, I'll just jump into in a minute, and I'll get to that. Here's some examples of some of the sonic survey equipment. You can have some that's just a very basic listening equipment, and then others that are have filters to filter out vehicle noise and electrical hum and all these sorts of other things as well. Here's just an example out in East Bay, just using some of the different types of equipment from sonic survey down in the bottom right, correlator survey in the bottom left, and then some of the acoustic surveys in the top two, putting some of the acoustic equipment on the valve nuts. And again, transmission has it's a very different animal in terms of determining leakage. Analysis of pressure transients are important, and you need to connect direct to the water column if you're going to do it properly. A lot of the acoustic methods for distribution and service lines can be just attached to the outside of the pipe, but realistically, once you get above a certain size, 16, 20, 24-inch pipelines, you need to connect the sensors to the water column to get any sort of value out of the surveys. And just one thing before we jump over to the district area side of things is, I have this a lot, this question a lot. Okay, well, how much water is coming from the different areas of transmission, distribution, and service lines? A lot of people believe that transmission mains provide the most leakage to the system. And in fact, that's not the case in almost all circumstances, because those come to the surface very quickly, they become big problems, and they're shut off very fast. And so there's an awareness time, a location time, and a repair time. That's the A, the L, and the R there. And the awareness time and the location time for large main breaks is very short generally. The repair time is relatively short. Once you get down to the smaller systems, you may never see them. It may either go down a sewer, or it may just never surface because of the ground conditions. And so the awareness, the location, and the repair time is significantly increased on the utility side, and on the customer side, it's even more so. So that's just a reference point there. So a DMA, PMA. So that's district metered area or pressure management area. So you can manage pressure to improve leakage as well. And so we'll get into that. So what is a district metered area? So this is it's a zone. It's a separate zone within a utility system, usually between 1,000 and 3,000 connections. That's the sort of size range that's optimal. and you break it down to that area, and you put a meter into the system so you can monitor what's going into the system, and hopefully with your metering systems, you can get some kind of analysis of how much, what the demand is, what the customer usage is within that district as well. So you can do a balance on a daily, monthly, depending on your metering system, daily, monthly, or whatever. But even if you don't have the meter data, if you just monitor flow into that district, you can still gain some value out of it with respect to leakage. So this is an example. It's actually from Scotland in the UK, just as an example, but it's true across everywhere that does this kind of work. This is a daily cycle flow into a district area. So you can see the rise and the fall, of 7 days before the drop in the red line, and then a little bit more than 7 days afterwards. So you can see 7 days of daily cycle. Put the dotted line at what we call the minimum night flow. That's the middle of the night. That's the minimum flow. That's the dotted line. So you see, and you can see it drops over time. So there was a leak repaired at that specific point in time. And then there was a certain reduction in night flow after the repair. You can do that just, as I said, through monitoring the flow into the district. And then you can see where there is, when you see a drop in it, then you can work out how much volume was from the leaks that you just fixed. You can use it obviously in the other direction as well. If you've got a low night flow and then suddenly it increases, more than likely there's a leak in the system. And so you can go and send your leakage teams out, or get a contractor out to actually have a look in that zone. So it's a management tool. And before I get to the apparent losses, this is just the last item I want to mention as well. So this is a true example as well. It's from a long time ago, just to show that this sort of work has been going on for a long, long time. It's actually from a utility in Australia, and it's related to the number of breaks in one of these zones. As you manage pressure and in an area, and that doesn't mean always reducing it. It can mean stabilizing the pressure. That has a significant effect on the number of main breaks that there are in the utility. And if you do reduce pressure, if you're able to, some utilities are not because they're already running at relatively low pressure. But if you've got a high pressure in your system, then you can, that's a very good tool to helping with reducing of main breaks and reducing of real loss as well. As you can see, this there was pressure management, a reduction in pressure and a stabilization of pressure at this specific utility significantly reduced the number of main breaks over that period when pressure reduction was commenced. Okay, so on to apparent losses. So this is again metering errors, meter inaccuracy, unauthorized consumption or theft, and data handling errors. So with customer metering inaccuracies, you need to look at the meter demographics and conduct regular meter accuracy testing. That's hugely important across all large and small utilities. Theft of service is generally the most difficult thing to understand, but that requires analysis of the billing system to see where there's anomalies and oddities, and then fieldwork to go and check to see if there is an issue. And it's the same with the data handling errors. You do that forensic billing analysis where there are anomalies. Maybe this one looks 10 times lower than it should have been. Is it a meter multiplier related to its peers? Those sort of things that you need to connect to. With respect to the meter inaccuracies, meter testing is hugely important. And this is just an example of a test bench. Some utilities have them. Many utilities don't, but there's contractors in every state, pretty much, or close to every state, that can do this for you. And the number of utilities who have test benches are more than happy to help out other neighboring utilities to do testing as well. I found that very common. But it's to do testing of all different sizes of meters, all the different manufacturers, and looking at different flow range analyses for that and weightage calculations. So I'm just going to show you a data set. This is actually a Texas data set, just so you know where it comes from, specific utility in Texas. And I'm just going to go through it very briefly. Down the bottom, you'll see the volume in units. That's in 100 cubic feet, CCF, and how much volume has gone through each of these meters. The test accuracy is on the y-axis from 0, it's failed, to 100% where it should be. And they're tested at 3 different rates. I wouldn't, we can go into that another time, but it's tested at a low rate, an intermediate, and a high rate. For a 5/8 inch meter, which this one relates to, that's a 1/4 gallon a minute for low, 2 gallons a minute for the intermediate rate, and 15 gallons a minute for the high flow rate. And so the low flow rate goes first. That's in almost all cases that degrades first. Very rarely goes above 100%. Almost always degrades below. But what I just want to show here is how that data set here looks as though there's no, well, I'll just go back. So that's the whole data set. And there doesn't look to be a huge amount of variation in that. It looks a little random. But then if you break it down as I'm going through it, this is up to just beyond the meter warranty for that specific meter type. And there doesn't seem to be much of a fall off in accuracy. But then if you move away from that into the rest of the data set, you can hopefully see the trend lines are going down. There's a degradation of accuracy. And as you increase the amount of flow that's gone through the system, that degradation of accuracy increases and increases. And this is, it's the laws of physics. If you, over time, things are going to degrade, things are going to wear, especially the mechanical meters. And so it is going to have that kind of a curve. But just so you can see that from an actual data set, but you need to have a look at how much volume has gone, of water has gone through the meters as well. Age is important too, but in volume is most important. And obviously this drives how you change out your meters. An example, not from North America, thankfully, but of theft of service. So this was an active pipeline, which had a whole host of illegal connections that were discovered, and obviously the photograph was taken. But yes, so this does happen in North America. Maybe not to the same degree as this, but people do still try to get free water if they can, and so it's something to look out for as well. So just quickly on data management to finish up. So you do want to still manage the data and provide dashboards, et cetera, to visualize and to show those people outside of the, well, both internal to the utility and maybe even external to the utility as well. How much is your total demand? How do you relate against your peers? What's the total cost to the utility? There are a number of different programs that can analyze that and develop that for you, or you can develop it yourself. GIS is very important to analyze, well, where are the problem meters? Where's the problem data? How should we go and field validate? Most utilities have some kind of level of GIS. So that's a very important mechanism to evaluate and look at the data. Then there's evaluation of the different meter sizes and really drilling down to specific problem areas. This is a specific one where the high values, or the customer usage is very high compared to the typical for that specific classification and meter size. There's actually a 10 times multiplier, and that's sort of suggested that it might have some issue. Not always the case, but it can help you drive into where those problems are. And you do analysis by meter type and meter size as well. This is an example of a fairly normal curve, but if you look at all this data and it's, one month is significantly more or less than another, obviously that drives you into the data sets to take a review and an analysis. And then just to connect back to the system water audit, just to remind everybody of that. And then very quickly, here's just 3 examples of, it's just from another utility, specific input from a utility where we were working a couple of months ago. Just, and maybe I'll just read the last one, they noted that we should be verifying wholesale customer meters at least annually. I assumed we did this already, but found in CityWorks that some of these meters have not been tested since we started CityWorks. So it's things like that. You also want, even as an auditor, you've got to get feedback as well. There's feedback all along this chain, and it's very, very important to make sure that you go through the process of validating, of auditing, of being honest with your data, and then constantly getting feedback and constantly looking for improvement from all sides. And so just to end, that's a very brief overview of the water audit structure, some of the mitigation techniques. I'd be more than happy to answer any questions now or into the future about any of those. But just to end, this is the North American Water Loss Conference that's happening in a couple of weeks' time over in San Diego. And we'd be more than happy for any of you that aren't currently going to go. Obviously, there's going to be all sorts of programs there, specific ones on meter testing, specific ones on apparent loss and real loss and pressure management and all the things that I've been talking about in much, much more detail. So Noah, maybe I'll end there and just pass it back to you, and feel free to move it on from here.
Okay, very good. Thank you very much, Andrew. That was very nice, and I hope very informative for all of our viewers. I'd like to thank all of our presenters, of course, for providing these very interesting presentations about the leak detection and water loss and the impacts here on a state level for those leak detection efforts. We have a few questions from the audience, and bear with me while I try to open this. I think there was just 2 questions, but my little dialog box is very small. So the first question, well, actually, we had 2 questions from Jeff. One said the word no, and the other said yes. I'm assuming he answered himself. The second, or third rather, was how do I document my PDHs for operator certification? If you would just send me an email, my email was in the notice as well as on the web page. It's noah.munt@siemens.com. I will then fill one out and sign it and send it back to you. So if anybody would like PDHs, please do that. The next one is what % of larger water utilities do water audits and what percentage of smaller? It seems like larger water companies would have the resources. So for myself, I'll answer that shortly by saying I believe every water company of any size or shape or form believes in their own minds that they're doing some form of loss mitigation or some kind of quantification. But I think that as we get into it, the real question is how valid is the efforts they're making and how do we do a standardization? But with that being said, Andrew, what are your thoughts on that?
Yeah, it's one of the reasons we actually developed the water audit software was to try and help those smaller utilities because they don't have as many resources. And it's set up so that any utility of any size can utilize it. So that's one of the things, and to have that developed. I would say that certainly overall large utilities, because they have more resources, probably do the M36 style methodology a little bit more than the others. But there are a number of states now that have sort of gone through the education process, and utilities of all sizes. As I mentioned, in Texas, they have 4,500 utilities, give or take, and 2,100 of them have gone through the process of auditing. Some of them are tiny, 10, 15, 20 connections, and so that's about 1,000 of the utilities in Texas that are that way. So obviously at that sort of level of detail, you probably don't do it. But once you get 1,000, 5,000 population, there's a lot of utilities that have done that in a number of states: Tennessee, Georgia, Texas, California, and there's been a number of utilities in Arizona that have done it as well, but they just haven't been mandated to. So a lot of the small utilities haven't done it. But yeah, it's maybe that. Hopefully that helps at least. And there's a lot of small utility data that's available from Georgia, as an example, and there will be from California very soon as well. Hundreds of utilities.
Right, exactly. Let's see. And then one more question. Andrew said to detect leaks in larger transmission lines, we need to, quote, connect to the water column. What does that look like?
Sure, good question. So realistically, if there's hydrants, air valves, blow-offs, a connection to the system, a gate valve, a corporation stop that connects to the transmission system in some form or fashion. So that's realistically what you need, is to put a sensor on one of those connected areas. Let's just take a hydrant as an example, even though I know a lot of transmission systems don't have hydrants. So you'd put a sensor on the hydrant and then open up the hydrant to connect it to the water column. Normally it wouldn't be unless you open the valve nut to the hydrant. And that then is a connected, that's connected to the water column. It can listen specifically to the acoustics, the signals that are going down the water column. Most of the other systems, you're just listening to the pipe. You're not listening to the water inside the pipe, and the sound travels more effectively in the water column than it does along the metal or the plastic of the pipeline.
Okay. Well then, unless anybody else has any questions that they'd like, I believe that was the end of the questions. And like I said, for all of those on here, if you were to have any questions as time goes on, feel free to reach out to me and the others. As I may have mentioned, we intend to make this a series of webinars several times a year in an ongoing effort into perpetuity, in order to kind of start to bridge the gap of knowledge between a lot of the members and a lot of the other individuals in the industry, like the people we've had here today, to help understand what's happening around the country and how we can use that here locally. We plan to make I recorded this. I'm not sure exactly what the protocols are. I believe we will have it available to attendees, as well as access to the slides, possibly via a PDF. I'll have to check with the webmasters, but follow up with me if you're interested in that. So in closing, I just want to say, the Arizona Water Association, AZ Water Association, has many interesting events planned in the future, much like this, and other kinds of site visits and things of that many of the other committees put on. Many of them are free events, or else very affordable. And like with this one, if there's ever a question of affordability and I'm putting it on, please reach out to me and I can help you out in that regard, as Siemens is okay with putting some sponsorships together for other attendees like students and the like. We're always looking for interesting topics and presenters, so send me any notes that you may have if you're interested, and you can send that to me through my email or the committee webpage. Either works. And if you're interested in learning more about the subjects of the Energy and Sustainability Committee, like I said, please join. We're always looking for new members. We meet monthly. So in closing, I want to say thank you to the Arizona Corporation Commission and Andrew and Britton for joining us today and giving us the overview of the work they are currently working on, as well as Sara from WIFA and Andrew from Black & Veatch, and of course, shamelessly, Siemens for myself. I also want to thank Bill Kenny and Eric Coppinger from Maricopa County for helping me to put this on, and hopefully all of you on the webinar thought that it went quite smooth and seamlessly, as well as Lisa Jackson from Black & Veatch for putting me in contact with Andrew and helping me set this up. And, the whole team at the AZ Water, between Asia and Debbie, for that as well. So thank you all for joining us. I hope you found this interesting. I look forward to speaking with you all again on a future webinar, and have a great Thanksgiving.